The final topic this week, or excuse me, this section 10.2 is going to be surface area. So we've talked tangents, area, arc length. So finally, we'll just end with surface area. And it's actually pretty straightforward. Again, just like arc length, it's just going to be another formula you're going to need to follow to evaluate the integral. All right, so let me give the definition with the formula here. So suppose the curve C given by the parametric equations as we've been defining them, where t is between alpha and beta, f prime and g prime are continuous, g of t is greater than 0, and we're rotating about the x-axis here. If C, the curve, is traversed exactly once, so in the previous section I talked about going around twice, but this is just once, as t increases from alpha to beta, then the area of the resulting surface, so just the surface area, is given by S, surface area. The integral from alpha to beta, 2 pi y. Now, the thing when I put y here, remember it's going to be a function of t times the square root of what was the arc length formula. And this surface area equation should look very, very similar. If I were to replace this part with the arc length formula without parametric equations, this would have been something you would have done in Calc 2. So the general symbolic formula, surface area is 2 pi y ds. And S here is equal to 2 pi x ds are still valid, but for parametric equations, we just replace that ds. And the 2 pi x here is when you go around the y-axis. But the parametric equations we use here, ds, is just this arc length formula here, or the formula in the inside part of the arc length integral. All right, so just as we've done in the last two examples, all right, it's just following along this formula here to find the surface area. So let's do one example. All right, so let's just show that the surface area of the sphere, so the surface area of a sphere of radius r is 4 pi r. All right, so I want to use this equation here to find the surface area of a sphere for any radius. All right, it doesn't matter. We're just replacing any radius here with r. So it could be radius 5 or radius 10, whatever, it doesn't matter. All right, so I want to show that the surface area here is 4 pi r squared. All right, so here's what we know. The sphere is obtained. What you do is you're going to rotate the semicircle here. So a semicircle is given by x is r cosine of t, y is r sine of t. Right? That's just like on a unit circle, the x and y coordinates. From t is rotated from 0 to pi. That's it. So if you were to just graph this and this from 0 to pi, you would just see a semicircle. Right? And what we're going to do is we're going to rotate that semicircle around the x-axis. Right? And then when we rotate that semicircle around the x-axis, we'll get a sphere. And I want to just do the surface area of that sphere. All right, so the formula here, surface area is equal to the integral from 0 to pi. So 2 pi y, and remember y is r sine of t, square root this right here. Where did this and this come from? Remember, it's dx dt and dy dt. So this right here is derivative of x with respect to t, and this right here is the derivative of y with respect to t. So we just have to clean all this up, and hopefully you've done enough trig calculus here where you can see where this is going, and you can see that this is going to get us, r squared sine squared plus r squared cosine squared, and that's just going to be r squared, and then the square root is just going to be r. So hopefully you've done enough where you can just like, oh, I see where this is going. All right, so cleaning this up, this 2 pi here is just constant. So isn't the r, but an r is going to come out from here in a second. So 2 pi, 0 to pi, r, sine of t. Don't forget you have this sine of t here. This, which happens when I square it, right, and I factor out an r. So sine squared of t plus cosine squared of t obviously is 1. So then I'm just going to get the square root of r squared, which is r. So r and r are going to give me r squared. I'm simply going to take that out here. And then all I'm going to be left with is just the integral from 0 to pi sine of t dt, which would have been one of the first integrals you would have done in Calc 1. And that integrates as minus cosine of t. And you can just plug in now your bounds of integration. When you do, you're going to see, and plug these in, you're going to see that this is going to simply become like we plug in, pi into here, you're going to get negative 1. but then you're going to make it negative and it's going to become 1, and you plug 0 in and you get 1, but then minus minus becomes 1, so you get 1 plus 1 is 2, and that's how you get your 4 pi r squared. So take 2 and multiply it by 2 pi r squared. All right, so I know I've gone through some of these videos pretty quickly, but I encourage you to download them, watch the videos, and work through the examples yourself.